Here is our next topic, complex numbers. Complex numbers are very important, especially in electrical systems. Once upon a time, the square root of -1 was equal to no real solution. Let's take a look at the complex number system. We represent it by a plus bi. So you learned back in elementary school, you had your natural or counting numbers 1, 2, 3. Whole numbers included a 0. Then there were integers where you have negative numbers, 0, and positive numbers. Rationals can be written as fractions. Then we have irrationals. These cannot be written as a fraction and they go on forever. Our two examples here are pi and then Euler's number. Okay, and these are all called real numbers. And then we have our pure imaginary number, which has i's in it for imaginary. And these, the real numbers and the imaginary numbers, are joined by the complex number system. A is the real number and bi is the imaginary number. Since all numbers belong to the complex number field, C, all number can be classified as complex. The real number field R and the imaginary numbers I are subsets of this field as illustrated below. So you have all your real numbers, A plus, no imaginary part, and then you have your pure imaginary numbers, 0, plus or minus bi, the imaginary. A little history. Math is used to explain our universe. When a recurring phenomena is seen and can't be explained by our present mathematics, new systems of mathematics are derived. In the real number system, we can't take the square root of negatives. Therefore, the complex number system was created. Complex numbers revolutionized computer graphics and electronics and electricity. In the set of real numbers, negative numbers do not have square roots. Imaginary numbers were invented so that negative numbers would have square roots and certain equations would have solutions. These numbers were devised using an imaginary unit named I. I is equal to the square root of -1. The imaginary number consists of all numbers bi, where b is a real number and I is the imaginary unit, with the property that I squared is equal to -1. The first 4 powers of I establish an important pattern and should be memorized. So here's your powers of I. So I to the first power is equal to I, and remember that that is equal to the square root of -1. I squared means that we have taken two -1 square roots, multiplied them together, and we get -1. I cubed is equal to -I, which means we've taken 3 -1 square roots together. And then 1 is equal to the square root of -1 times 4 times, and that gives us a positive 1. If you think about it, you took the I squared and squared it again, so you get -1 times -1, which gives you 1. You can also see that it is an endless cycle as you go from I to I squared, I cubed, I to the 4th. So if you have no remainder, the answer is actually I to the 4th is equal to 1. If you have a remainder of 1, the answer is I. If you have a remainder of 2, the answer is -1. If you have a remainder of 3, the answer is -I. So let's take a look at this example here. We want to find the I of 22. We're going to divide the exponent by the number 4. So 22 divided by 4 is equal to 5, which would be 20 with a remainder of 2, because 22 minus 20 gives you 2. It is the remainder that tells you which I you have. So 2 gives the answer of -1. Okay, so you find that I of 22 is actually equal to -1. So let's take a look at some examples here. Like if we find I of 23, it's equal to -I. Well, how do we know that? Again, you're going to divide the exponent by the number 4. So 4 is your key here. 23 divided by 4 equals 5 with a remainder is 3. It is a remainder that tells you which I you have, and 3 is equal to negative I. You're going to find the other answers here. So find the I of 2006. That is correct. It's equal to a negative 1. You had a remainder of 2. Okay, find the I of 37. That's right. That was just equal to I, because the remainder of 37 divided by 4 is 1. Okay? Find the I of 828. Okay? That gives you a remainder. There is no remainder there, so it's just equal to 1. Okay? Because 4 divides perfectly into 828. All right, we're going to express these numbers in terms of I. Notice the square root of negative 5 can be rewritten by taking the negative square root of negative 1 out, which means that we have I square root of 5. So anytime that you see that you have a negative underneath the square root, you know that you can take out a negative square root of 1 and relabel that as I. Okay? So here we have a square root of negative 99. In this case, we take out the square root of the negative 1. But notice we can break the 99 down into square root of 9 and square root of 11. So now the square root of 9 gives us a 3, so we get 3i square root of 11. Okay? Here we're going to try this. This equals I square root of 7. I'm going to let you try the next one. That's right. The answer is going to be negative 6i. How about the last one, the square root of negative 160? That's right, it's 4i square root of 10. Now we're going to multiply together. So what happens when we take 47i times 2? It's just 2 times 47 is 94, but the I stays the same. What about 2i times the square root of negative 5? Now that negative square root of negative 5 means that we get to take out a square root of negative 1, which is an I. So now we have two i's together. Remember, I squared is negative 1, so it's negative 2 square root of 5. Okay, here we have a negative, and we have a square root of negative 3 times the square root of negative 7. So each of these gets an I taken out. So notice it's a negative I squared square root of 21. Well, I squared was a negative 1. So a negative times a negative 1 equals just a positive 1. So you get the square root of 21. So here's a little fun. Hey guys, want to meet my new friend? Sure, but where is he? He's right here. Why can't anyone else see you? Beats me. It's the imaginary number. All right, remember your imaginary unit is I, and I is equal to the square root of negative 1. And if you have I squared, it's equal to negative 1. Okay? If you have I to the cube, this is just different ways of putting it. That's an I squared times I. So then I squared is a negative 1. So that's why you have a negative I. And again, I to the fourth is I squared, squared again, and 1 squared, negative 1 squared gives you 1. All right, let's take a look at what happens when we have things in the complex numbers form. Complex numbers consist of all sums of real numbers A plus imaginary numbers BI, where A and B are real numbers and I is the imaginary unit. The real part is A and the imaginary part is B. Okay, we can add or subtract these together. 7i plus 9i equals 16i. We can also combine real and imaginary parts together. What do you think the answer for this is going to be? Okay, we're going to combine the negative 5 with the 2 and get a negative 3. We're then going to combine the 6i and the negative 11i and we'll get a negative 5I. All right, this one's a little tricky because we have a negative, so you want to distribute the negative first and then combine the real parts and the imaginary parts. What do you think you're going to get for the answer? Okay, notice that we'll get 2 plus 3I minus 4 minus 2I. Now that you can see the distribution a little clearer, what's going to be our answer? That's right, our answer is just going to be negative 2 plus I. Multiplying and dividing complex numbers. Now we have to be careful with our i's and we have to use our exponent rules, okay? So here we're going to have 12I squared. Remember, I squared is equal to negative 1. So this is going to become 12 times negative 1, and this will become negative 12. Here we have 7I squared. So we're going to have 7 squared I squared. So we'll get 49 times negative 1. So we get negative 49. Now you're going to try. Please do the first one. That's right. The answer is 84I squared, but the I squared is negative 1, so it's just 84. Here's the second one. So we'll get negative 11 squared and an I squared, right? You find the answer. So we'll get 121 times negative 1 for negative 121. Now we're going to multiply these together, and this is why you had to review your foiling. Okay? So when we FOIL our first ones, we get 4 times 7 is 28. When we FOIL the 4 times 2I, we get 8I. Then we're going to FOIL the 3I times 7 for 21I. Then we're going to FOIL the 3I times 2I for 6I squared. Okay? Then we're going to combine our I terms. 8I plus 21I is 29I. Then we are going to change the I squared to a negative 1. Notice then that we can combine the 28 and the negative 6. So we get 22 plus 29I. And this is the answer. Again, you had to FOIL. You try this. I'm going to give you some time, okay? Alrighty, let's walk through it. So we'll get 2 times 3 for 6. We get 2 times 10I for 20I, negative I times 3 for negative 3I, and then negative I times 10I for negative 10I squared. Combine the 20I minus 3I, we get 17I. Add 6 minus 10I squared, that I squared, negative 1. Then add the negative 10 and the negative 1 become 10. Positive 10, we have to combine our numbers, and we get 16 plus 17I. Okay, go ahead and you try this one. Alrighty, we got 5 times 5 for 25, 5 times negative 7I for a negative 35I, 7 times 7I times 5 for a positive 35I, and then we have 7I times a negative 7I for negative 49I squared. Notice that our middle terms cancel, so we really get just a real number because 25 plus 49 is 74. Keep that in mind. The 5 plus 7I and the 5 minus 7I are what we call conjugates, and we're going to study those next. See, here it is, a conjugate. Okay, the conjugate of A plus B is A minus B. And the conjugate of A minus BI is A plus BI. So find the conjugate of each number. You give it a chance. So 3 plus 4I has a conjugate of, that's right, it's 3 minus 4I. And negative 4 plus minus 7I has a conjugate of, that's right, it's going to be negative 4 plus 7I. What about the conjugate of just a 5I? That's right, it's negative 5. I. And 6, would it have a conjugate? No, because it's a real number and does not have an imaginary part. Okay? All right. So when we go to divide our imaginary numbers, we have to use the conjugates. So we have 1 minus I in the denominator. So we have to multiply the top and the bottom by 1 plus I using the conjugate. Notice that in the denominator, our I terms are going to cancel. And in the top, you are going to FOIL. So you get negative 5 times negative 5I. You get plus 9I plus 9I squared. Okay? We then combine like terms at the top. So we wind up, remember that the 9I squared turns into a negative 9. So we wind up with negative 14 plus 4I. And then in the bottom, we have 1 minus I squared. Well, I squared is negative 1. So we get negative 14 plus 4I over 2. Well, we can simplify this further. Please notice that we divide both the 14 and the 4I by 2. Okay, we're going to try this again. All right, so again, what is our conjugate going to be? That's right, it's going to be 3 minus 5I. Then we have to FOIL the top and the bottom. So we get 6 minus 10I minus 9I plus 15I squared for the foiling on top. Notice on the bottom we get 9 minus 15I plus 15I. Those two are going to cancel. Minus 25I squared. So we wind up, when we combine terms, with minus 9 minus 19I with 9 minus 25I squared. The 25I squared, remember that I squared is a negative 1, so you wind up adding the 9 and the 25. There's nothing here that's going to simplify, so that is our answer.